Ladies and gentlemen, welcome to this episode of my tutorial video channel. In this video, I will discuss unbounded solution in linear programming problem, in short LPP. In my earlier video, that is on part 1 and part 2, earlier videos in part 1 and part 2 both, I have discussed what is linear programming problem and how linear programming problem can be formulated and how they can be solved. So for a quick recap, linear means the relationship between the variables can be represented by a straight line. This means the variables are linearly related, and programming means making a decision thoughtfully or solving a problem thoughtfully or with proper planning. Mathematically, linear programming problem refers to formulation and solution of problems where a linear objective function has to be optimized subject to a set of linear constraints, and at least one of those constraints must be expressed as inequality. In my earlier videos, we have faced very well-behaved problems. That means we have found out optimum solutions. But there can be situations where you won't be able to find a finite solution or optimum solution. That is called unbounded solution. When the values of the decision variables are allowed to increase infinitely, then an unbounded solution is said to exist. In such cases, the value of the objective function can also be increased infinitely. So let us take an example and discuss its mathematics. We have taken the objective function as max z equals to 3x plus 2y, subject to x1 minus x2 is less than equal to 1, x1 plus x2 is greater than equal to 3, and x1 and x2 both are greater than equals to 0. So these are the three subjective functions, and you have to maximize z equals to 3x plus 2y. So we start with the constraints, the subjective functions. First we take equation 1. Equation 1. What is that? x1 minus x2 equals to 1. Now putting x1 equals to 0, we get 0 minus x2 equals to 1, or x2 equals to minus 1. So we get one set of values as x1 equals to 0 and x2 equals to minus 1. This is one set of values. We have taken equation number 1, that is x1 minus x2 equals to 1, and we have put x equals to 0, so we have found out 0 minus x2 equals to 1 or x2 equals to minus 1. So the values are x1 equals to 0 and x2 equals to minus 1. Now putting x2 equals to 0, we get, what do we get? x1 minus 0 equals to 1, or x1 equals to 1. So we get so you get another set of values as x1 equals to 1 and x2 equals to 0. Now we can draw the straight line joining these 2 points, these 2 coordinates. This is 0, 1, 2, 3, 1, 2, 3, 4, 5. 0 minus 1 is 1 value. Minus 1, minus 2, so on. So 0 minus 1, this is 1 value. 0 minus 1 coordinate. This is 0 minus 1. Another coordinate is 1, 0. It is here. 1, 0. We join these 2 points by a straight line. So this is x1 minus x2 is equal to 1. That is equation number 1. The equation of this straight line is x1 minus x2 is equal to 1. Now take equation 2. What is the equation? x1 plus x2 equals to 3. So we take x1 plus x2 equals to 3. Putting this is x1, this is x2, this is minus x2. Now putting x1 equals to 0, what do you get? We get 0 plus x3 equals to 0 or x3 equals to 0. x2, 0 plus x2, so x2 equals to 0. We have taken the second equation, x1 plus x2 equals to 3, and here first we have put x1 as 0, so 0 plus x2 equals to 3, so x2 equals to 3. Okay, 0 plus x2 is 3, so x2 equals to 3. So we get here a set of values as 0, 3. Now putting y equals to 0 in equation 2. Not y, we are considering x2. Instead of y, it is x2. So putting x2 equals to 0 in equation 2, we get x1 plus 0 equals to 3 or x1 equals to 3. So we get another set of values as 3, 0. Okay, here x equal to 0, x1 equals to 0, x2 equals to 3, and here x1 equals to 3 and x2 equals to 0. So we get 2 coordinates 3, 0 and 0, 3 from equation number 1. So 1, 2, 3, 3, 0, this is 1 point, 3, 0, and the other one is this is 0, 3, and the other one is 3, 0. Sorry, this is 3, 0, 3 0, and the other one is 0 3, 1 2 3. This is 0 3. Now you can join these two coordinates by straight line. So this is which equation? This is x1 plus x2 equals to 3. Now these two straight lines intersect at this point. Let this point be A. Now carefully look at the whiteboard. We have obtained an unbounded solution. Why? Because the feasible solution space is unbounded. It ranges to infinity. Only 2 points on the finite plane are these 2 points, A and let this be B. Only A and B are 2 points which are on the finite plane. The rest of the solution lies on infinite plane. So the feasible solution space is unbounded. The only points on the finite plane are A and B. We know the coordinates of B, but we don't know the coordinates of A. Here we shall find out the coordinates of A. So coordinates of A. We solved these two quadratic equations, that is two constants, two linear constants. It is x1 minus x2 equals to 1 and x1 plus x2 equals to 3. This is equation 1, this is equation 2. We will simply solve these two quadratic equations. Subtracting 2 from 1. What do you get? What do you get? Minus 2x2 equals to minus 2. Therefore, x2 equals to minus 2 by 2 equals to minus 2 by minus 2 equals to 1. Now putting the value of x2, putting the value of x2 in equation 1, we get x1 minus 1 equals to 1 or x1 equals to 2. So the coordinates of A two, x equals to 2, y equals to 1. X equals to 2, y equals to 1. This is the coordinate of A. 2 and 1. Now let us see the values of Z. max values of Z. Vertices X, Y and Z. So vertices A has the coordinates 2, 1 and B has the coordinates 0, 3. So Z equals to 3x plus 2y. We have made a table consisting of 4 columns: vertices, value of x, value of y and value of z. Z is equal to 3x plus 2y. Now we are putting the values of the coordinates. The two coordinates, those are on the finite plane, that is point A and point B. The coordinates of point A are 2 and 1 and coordinates of point B are 0 and 3. This is x1, this is x2. This is 3x1 plus 2x2. The objective function is 3x1 plus 2x2. Instead of y, take it as x2. Okay. The objective function is z equals to 3x1 plus 2x2. So now you can find out the values of different values of z by putting the coordinates of A and B. So here it is. Here it is 3 into 2 plus 2 into 1, that is equals to 6 plus 2 equals to 8, and the value of coordinate B 3 into 0 plus 2 into 3 equals to 0 plus 6 equals to 6. So the maximum value is, prima facie the maximum value is A, but Z is not at maximum at coordinate A, right? So we have found out ZA equals to 8 and ZB equals to 6. Now consider one point here or one point here. Any point you consider, the coordinates of these points, that is on the infinite plane, will give much bigger value than ZA or ZB. And there is no limit that can be stretched to infinity. So you cannot find out any optimum solution in such problems. Okay. In my previous videos, I have discussed relatively simpler LPP problems, and here I have discussed one exception, that is unbounded solution. Situations may arise when there is no optimum solution to the LPP. We have taken one example. The objective function is 3x1 plus 2x2, max z equals to 3x1 plus 2x2, and the constraints are x1 minus x2 is less than or equal to 1, x1 plus x2 is greater than or equals to 3, and x1 and x2 both are more than 0. These are the three linear constraints, and we have to maximize z, which is equal to 3x1 plus 2x2. So we have started with the constraints. First we have taken equation number 1, that is x1 minus x2 equals to 1. Then we have put the values of x1 as 0. So we have found out one set of values as 0 and minus 1. Then we have put x2 equals to 0 in equation 1. and we have found out another set of values as x1 equals to 0 and x2 equals to, sorry, x1 equals to 1 and x2 equals to 0. Now we have plotted those coordinates and found out this straight line, that is x1, the equation of this straight line is x1, this straight line x1 minus x2 equals to 1. With these two coordinates, it is this one, and we are ultimately extended the straight line. So this is the equation x1 minus x2 equals to 1. Now we have considered equation number 2. Equation number 2, that is x1 plus x2 equals to 3. Here again we have put x1 as 0 and found out x2 equals to 3. So one set of values are x1 equals to 0 and x2 equals to 3. Then we have put x2 equals to 0 in the equation and we have found out x1 equals to 3 and x2 equals to 0. We have plotted these two coordinates, that is 0, 3 and 3, 0, 0, 3 and 3, 0, these 2 points, and joined these 2 points through a straight line. So x1 plus x2 equals to 3 is the equation of this straight line. Now these two straight lines intersect at point A. So we have found out an unbounded solution, that is the convex region above this line. We have only 2 points, 2 coordinates which are on finite plane, and those coordinates are A and B. All the other coordinates lie on the infinite space. So that is called unbounded solution. We have found out the coordinates of A by solving these two quadratic equations, x1 minus x2 equals to 1 and x1 plus x2 equals to 3. We have simply subtracted 2 from 1 by subtracting 2 from 1. Here we have subtracted equation 2 from equation 1 and we have got the value of x2 as 1. Now putting the value of x2 in equation 1, that is in this equation, we have got x1 equals to 2. So the coordinates of point A are x2 equals to 1 and x2 equals to 1, x1 equals to 2 and x2 equals to 1. x1 equals to 2 and x2 equals to 1. That is this point. And value of ZA, that is the coordinate 0, 3, coordinate 2, 1, value of ZA is coordinates 2, 1, that is 3 into 2 into 2 into 1, that is 8. And the value by putting the coordinates of B, we get 0, 3, 3 into 0 plus 2 into 3, that is 6. So prima facie, this is max Z. It seems that it is max Z, but actually not. This is not max Z. Z is not maximized at point A. We can find out enumerable points on the infinite plane which give much higher value than ZA gives. Okay, so this is unbounded solution in LPP. This is all about LPP's unbounded solution. I believe this is well understood by you. Still, should you have any doubt in your mind, if you have any question, please feel comfortable to let me know through the comment box. I shall be very happy to respond to all your relevant queries. And if you think this video is beneficial for you, please do share the video with your friends, brothers, sisters and colleagues so that they can also get benefit by watching this video. And finally, thank you very much for your precious time. Stay well and goodbye.